Alright guys, so today we are back with graphing parabolas. However, you will notice through the examples in today's lesson, we're going to look at 4 different examples. These parabolas have something special going on with them, whether they're a special case polynomial or whether they're points or the parabola doesn't have x-intercepts. So you'll see with each example that we do that there's something special going on with each one. So without further ado, we'll go ahead and dive in. So for our first parabola here, we have y equals x squared minus 4x plus 5. The first thing that I like to do is identify my a, b, and c value, since I need both a and b when I'm finding the vertex, the x-coordinate of the vertex, and the axis of symmetry. So my a value here, right, in front of this x squared is really 1. My b value is negative 4. Let me move this over a little bit. My b value is negative 4, and my c value is 5. Okay, so we talked about how the axis of symmetry is that vertical line that contains the vertex. And we talked about how when you find the x-coordinate of the vertex, in other words, you're finding the axis of symmetry. So for either one, if you're finding the x-coordinate of your vertex, you're finding the opposite of b over 2a. But since we know the axis of symmetry is the vertical line that goes through this x-coordinate, the axis of symmetry could also be found by doing negative b over 2a. So what's nice about this is you kind of get a little bit of information. If you do this here, you've gotten the axis of symmetry for free. So anyway, I'll just kind of show my work here. The opposite of b, so I have that b is negative, so the opposite of negative 4, highly recommend you plug that in with parentheses, over 2 times 1. The opposite of negative 4 is positive 4 over 2. I get that the x-coordinate of my vertex is 2. So again, I did all that work here, so that means the axis of symmetry is 2. And just to jog your memory, since the axis of symmetry is a vertical line, and all vertical lines have an x equals equation, so kind of keeping that in mind. Okay, so to find the y value of our vertex, you're going to take that x value you just found and plug in for x in the original equation. So I'm going to take this 2, and I'm going to plug it in for x in my original equation to solve for y. So I have 2 squared minus 4 times 2 plus 5. 2 squared is 4. 4 times 2 is 8. 4 minus 8 plus 5. 4 minus 8 is negative 4. Negative 4 plus 5 is positive 1. So now I know that my vertex is the point 2, 1. And I'll box that out so that I have that. Here's my axis of symmetry. Okay, so now we're at the point of finding the x-intercepts. Okay, so at this point, to find the x-intercepts, what we do is we set our equation, x squared minus 4x plus 5, we set it equal to 0. And if you notice what's happening here, we're replacing y with 0. And if you think about it, if you're anywhere on the x-axis, that means that the y value is 0, right? For example, if I'm over here, I'm just saying hypothetically, if I'm looking at this point would be negative 5, 0. If I was looking at this point, that point would be 2, 0. If I was looking at this point, that point would be 5, 0. So anywhere on the x-axis, the y value is going to equal 0. That is why when we're trying to find x-intercepts, we plug in 0 for y. And I'll even write that here. Plug in 0 for y. Okay, so without further ado, this should remind you of the zero product property. We are going to factor, if we can, set each factor equal to 0 and solve. So I know x times x is x squared. And when I'm looking for two numbers that multiply to give me 5 and have a sum of 4. So I'm thinking, okay, well, the only numbers that multiply to give me 5 are 5 and 1. if this is positive, then that means that my signs have to be the same. If this is negative, that means I'm looking for a negative sum. And when I check this, I see I get negative 1x and negative 5x gives me negative 6x. So this doesn't work, and I don't have any other options. So what we're noticing here is that this is prime. This is a prime trinomial, which means we have no x-intercepts. So we're going to have to talk about a way to graph otherwise. Right now, we've been using the vertex, the x-intercepts to graph, so we're going to have to be a little bit more strategic. Let's get our final piece of information here, the y-intercept. And if you think about the y-intercept, we talked about how in our investigation, the c value is the y-intercept. And just like when we're on the x-axis, if you want to be on the x-axis, y is 0. Well, the opposite is true for our y-intercepts. If we're anywhere on the y-axis, then that means that our x value has to be 0. So in other words, to find the y-intercept, we plug in 0 for x. So I'm kind of running out of space here. Let me squeeze this in. We plug in 0 for x. And then if you notice what ends up happening, well, x squared minus 4 times x plus 5. When you plug in 0, 0 squared is 0. 4 times 0 is 0. And you're just left with 5. So our y-intercept as an ordered pair is 0, 5. Okay, so let's go ahead and look at the graph here and plug in, kind of graph what information we have. So we know our vertex is going to happen at positive 2, 1. And we know our y-intercept is happening at 0, 5. And I know my axis of symmetry is the vertical line, and I always draw it as a dotted line. You could draw it as a solid, but I draw it as a dotted line to kind of show it's the axis of symmetry. So we know that our axis of symmetry is the vertical line that goes through our vertex. So I kind of have an idea of what's going on here, right? I kind of have this half, and I'm just kind of drawing a curve here. It doesn't have to be perfect. Just let me try to make it more U-shaped. Now, the problem is I don't have another point on this side to the right of my axis of symmetry to plot. However, since parabolas are symmetrical, we can reflect this y-intercept over the axis of symmetry to get us a point on the right-hand side. And that's exactly what we're going to have to do. So since this y-intercept is 2 points away from the axis of symmetry, we're going to count 2 points away to find this point, which will help us give us the other side of this graph. So now we have an idea of our parabola. Notice how we said there were no x-intercepts, right? When we tried factoring this, we got that it was prime and that there are no x-intercepts. And that's because our parabola opens up, and the vertex, the lowest point, the minimum, is above the x-axis. So this parabola is never going to intersect the x-axis because the vertex, the minimum, is above the x-axis. So just to kind of summarize what we did here, a little note that we can write is that we need to use the y-intercept, and axis of symmetry to reflect the third point. Technically, you need 3 points to graph a parabola. You need the vertex, and you need a point on either side of the vertex to give you an idea of the width. So that's a strategy that you might have to use going forward, and that's what makes this parabola here special, is that it doesn't have x-intercepts, and because of that, it's hovering over the x-axis, and therefore you have to reflect that y-intercept to get that third point. Okay, let's go ahead and take a look at this example here. Whoops, let me kind of fix this. Okay, good, you can see the whole thing. All right, so looking at this example here, again, same thing. I like to start off by writing out what's A, what's B, and what's C. Now, to jog your memory, your equation, your quadratic in standard form is ax squared plus bx plus c. A lot of students get confused here. Some of them assume that the second term is automatically b. But if you notice, our b term has to be attached with an x. So in this situation, the 4 is not actually the b term because there's no x next to it. The 4 is actually our c term. We don't have a b term. That makes it 0. And our a here, if this is a negative x squared, that really means that our a is negative 1. So just like before, we're going to go ahead and find the vertex, the axis of symmetry. You know that by finding the x-coordinate of the vertex, we are finding the axis of symmetry. I'll do the work over here. So the opposite of b over 2a, well, the opposite of 0, there is no such thing because 0 is neutral, so it's just 0. And 0 over 2 times negative 1, well, we've talked about this. It doesn't matter what's in the denominator. 0 over any number would end up just giving us 0. So our axis of symmetry is when x equals 0. So when x equals 0, we're here. The vertical line when x equals 0 is also known as the y-axis. You don't have to write both, but it is helpful to know when you're graphing your axis of symmetry. Okay, so now that we have the x-coordinate of our vertex, and I'll fill that in down here, let's go ahead and find y. So I'm going to take my x value and I'm going to plug it in to find y. When I plug in 0 here, we know what ends up happening. The opposite of 0 squared cancels, and we're just left with 4 as our y-coordinate of our vertex. So our vertex is 0, 4. Okay, to find the x-intercepts, like we said before, we want to plug in 0 for y. So our equation was negative x squared plus 4, y equals negative x squared plus 4. We're going to set that equal to 0. Now, whenever you have a negative leading coefficient, you want to factor that out. It will make it easier to factor out that negative, like a negative GCF. It will make it easier later on to factor further. So for this, I'm going to factor out this negative, which means that negative 1 times x squared gives me negative x squared. Negative 1 minus 4, negative times a negative, would give me positive 4. And now if you notice, we have what's called a difference of squares. Difference of squares is when you have a perfect square minus another perfect square. So what ends up happening here is we can factor this into x plus 2, the quantity of x plus 2, and the quantity of x minus 2. This is what makes this parabola a little bit special, is that we have this difference of squares here, this special case polynomial. Okay, so now from here, whenever you have a GCF that does not have a variable, it ends up canceling out. So you could say like negative 1 equals 0. That doesn't make sense. Therefore, the GCF, when numerical, when it's a constant and doesn't have a variable, cancels out. Next, we'll set each factor equal to 0. And I'm running out of a little space here. I'm going to work in the margin here. Subtract 2 on both sides. I get x is negative 2. Add 2 on both sides. I get x is positive 2. And I'm going to list these as ordered pairs to make it easier for when I actually graph up here. So since it's an x-intercept, that means the y value is 0. So there are my x-intercepts. And now the only thing left to do is find the y-intercepts. So just like before, the y-intercept is when x is 0, but if you notice, this x is 0. So it happens to be that the y-intercept is also the vertex. And you might remember that from when we were doing our parabolas investigation. So going ahead and graphing these points, I'll start with the vertex. I have 0, 4, so 0, 1, 2, 3, 4. There's my vertex. My x-intercepts are -2, 0, and +2, 0. And if you notice, when I connect this, I end up getting a parabola, this U-shaped curve that opens down. And this leading coefficient, oops, let me try to draw an arrow here. This leading coefficient, since it's negative, is telling us that this parabola opens down. And you can kind of see that as you graph your vertex and your x-intercepts, that this vertex is the highest point, or in other words, the maximum point on this parabola. You could come in and draw a dotted line over the y-axis. It's a little hard to see though for your axis of symmetry. Okay, let's go ahead and take a look at the back. Okay, so looking at this one here, kind of move over. Can you see the whole screen? Yes, okay, let me just scroll down a little bit. Move down. Okay, so for this one I can see I do not have a negative in front of my x squared. In other words, a is 1. So since a is positive, my parabola is going to open up. I can see my b value, remember it's ax squared plus bx plus c. Just because this is the last term does not mean it's c. This is a b value. This -2 is b because it's the coefficient of x. So b is -2, and c in this case is 0. Okay, so as before, we'll go ahead and find both the vertex and the axis of symmetry first. The x-coordinate of the vertex is -b over 2a. For this one, I get the opposite of -2 over 2 times 1. The opposite of -2 is +2 over +2. Gives me my x-coordinate of my vertex as 1. And I can go ahead and fill that in here. So I know my axis of symmetry is when x equals 1. Okay, now to find the y value of my vertex. So here I have y equals x squared minus 2x. I'm going to plug in my x coordinate to find the y of my vertex. So I have 1 squared minus 2 times 1. By the way, if this was a negative, you would want to plug it in with parentheses. You might want to get into the habit of using parentheses anyway, so that way you're always using them. But remember, and I'll kind of write it down here, remember that, for example, like -5 squared, not in parentheses, versus 5 squared. So this is telling you the opposite of 5 squared. 5 squared is 25. The opposite of 25 is -25. This is telling you square -5, meaning multiply -5 times -5. The 5's included in this, the negative's included in the squaring, which gives you +25. So there is a difference. These two are not equal, and that's why it's really important when you're plugging in your negatives, you use parentheses. Okay, you can't really see that squared here, so let's fix that. All right, so now it's just a matter of simplifying. 1 squared is 1, -2 times 1 is -2, and when we end up solving here, we get y equals -1. So our vertex is +1, -1. Now it's a matter of finding our x-intercept. So when you're on the x-axis, y is 0. Set your equation equal to 0 instead of y. In this situation, since I have a binomial, I'm going to factor by pulling out the GCF. And I can see here the GCF is just x. I'm left with x minus 2. And now, because this GCF is a variable, I do have to set it equal to 0. It's when your GCF, let me kind of show you the difference. It's when your GCF is just a constant. For example, over here, when your GCF is just a constant, it ends up canceling out. However, when your GCF is a variable, you have to set it equal to 0. Or when your GCF even contains a variable, you have to set it equal to 0. Okay, so I already found out x is 0 here. I would add 2 to both sides and get x is positive 2 here. And as my x-intercepts, as ordered pairs, that would be 0, 0, and 2, 0. So there are my x-intercepts. My y-intercept is just the c value, because again, when you plug in 0, 0 squared cancels. Here, 2 times 0 is 0. So my y-intercept is just the origin. Again, it's the c value. Since c is 0, my y-coordinate is 0. In order to be on the y-axis, x has to be 0 as well. So now I'm going to take these points and go ahead and graph them. So what makes this one a little bit special is that we're looking at a binomial when we factor this. Okay, so graphing this, I'll start with my vertex. I want positive 1, negative 1. My x-intercept, notice how 0, 0 isn't, oh, you can't see what I'm doing. Notice how 0, 0 is an x-intercept and a y-intercept. The origin is the only point where the point is both an x-intercept and a y-intercept, because it's on both the x and y-axis. And then positive 2, 0 is our other vertex point. Our other x-intercept. There's only one vertex point in a parabola. I misspoke. I apologize. There's my axis of symmetry. And then this one, it's kind of hard to determine how wide or how narrow it's going to be. So we're just going to kind of draw it the best we can. We only really know what's going on over here. And that's okay. And now looking at this parabola, I can see that since it opens up, the vertex is the lowest point, or in other words, the minimum of my parabola. So to kind of summarize that, if your parabola opens up, like here, your vertex is a minimum. But if we look at number 2 here, if your parabola opens down, your vertex is the highest point. It's the maximum. And I think that will kind of make more sense as you start practicing and graphing them a little bit more on your own. Okay, so looking at this last example here, just like before, we'll kind of approach it the same way. When our equation is in standard form, again, that's ax squared plus bx plus c. So I'm seeing here I have all of my terms. I know that a is 1, b is 4, and c is also 4. And as I'm looking at this, I'm able to determine or notice or make the observation that this happens to be a perfect square trinomial. Now, if you don't notice that right now, no big deal. You'll probably notice it when we get to solving for our x-intercepts. But I noticed it, I figured I'd point it out. Okay, so just like before, we'll find the axis of symmetry while we find the x-coordinate of our vertex. And plugging in, so my b value is 4. The opposite of 4 is negative 4 over 2 times 1. Negative 4 over 2 simplifies to negative 2. Oops. Said it, but I didn't write it. Okay, so now down here, I can start to fill in my vertex. For my axis of symmetry, I have that's happening at when x is negative 2. Okay, so now it's a matter of finding my y-coordinate of my vertex. So y equals x squared plus 4x plus 4. I'm going to take this negative 2. Notice how this is a negative 2, so I'm going to plug it in, definitely using parentheses. Negative 2 in parentheses squared plus 4 times negative 2 plus 4. Negative 2 times negative 2 is positive 4. 4 times negative 2 is negative 8. Plus 4. when I simplify here, positive 4 minus 8 is negative 4. Negative 4 plus 4 is 0. So the y-coordinate of my vertex is 0. So if you notice, since the y-coordinate of my vertex is 0, that means that my vertex is actually an x-intercept. But I want to show you how to factor to kind of verify that. So just like before, when we're looking for x-intercepts, we're going to plug in 0 for y. So instead of y, we have 0 equals x squared plus 4x plus 4. And if you notice that this is a perfect square trinomial, it might make factoring easier. However, if you don't notice, it's no big deal. And I'm going to actually treat it like I don't notice. So I know x times x is x squared. Now I'm looking for two numbers that multiply to give me 4 and have a sum of 4. So when I think of two numbers that multiply to give me 4 and add to give me 4, I'm thinking 2 and 2. In order for these two numbers to add to be positive 4, they both have to be a positive 2. So if you notice what's happening here is we end up getting the same exact binomial times itself, which I can rewrite as the quantity of x plus 2 squared. Now, since these binomials are exactly the same, or in other words, I just have one binomial being squared, I can essentially just set that one binomial equal to 0. And when I solve here, I would end up subtracting 2 on both sides, and I would get x equals negative 2, which as an ordered pair would be negative 2, 0. And that is how we kind of can confirm with our vertex here that the vertex is the x-intercept. Again, we're only getting one x-intercept, and I'll even write that here. Only one x-intercept because the quadratic is a perfect square trinomial. Okay, and then finally we just have to find our y-intercept. Again, that's when x is 0. So what if you take a look up here? Yeah, you can see 0 squared is 0. 4 times 0 is 0. That ends up canceling out. And you're just left with a y-intercept of 0, 4. Again, if you want to see the work, you would plug in 0 for x, and you end up seeing how that cancels out. And therefore our y-intercept is 4. So that perfect square trinomial, the fact that you only have one x-intercept, which happens to be the vertex, is what's going to make this, or is what makes this parabola special. And we'll kind of see as we go ahead and graph. So I'll start with the vertex. It's negative 2, 0, which is the x-intercept. So I've graphed both. And then my y, excuse me, my y-intercept is 0, 4. I know my axis of symmetry is the vertical line that contains my vertex. So this should kind of remind you a little bit like number 1. In number 1, we had the vertex, we had the y-intercept, and we had to reflect this point over the axis of symmetry to get this point here. In number 4, we're going to have to do the same thing. We have this point. I can see this side of the graph. However, I'm going to have to reflect that point over the axis of symmetry. I can see this is 2 points away, or 2 units away. So this is going to be 2 units away to get another point on the other side. So for this one, we also had to reflect the y-intercept over the axis of symmetry to get the third point. So that happens here and there. That's kind of a common theme with some of these more special case parabolas. So if you find that you're short on points, right, you only have the vertex and another point, you're missing the opposite side, keep in mind that you can use the reflection piece, that parabolas are symmetrical, to reflect one point over the axis of symmetry, and that should help you get your full parabola, your full U-shaped curve. Oh, I forgot. By the way, since this parabola opens up, and I can tell by the way we graphed it, but also because A is negative, this vertex is the lowest point, in other words, a minimum. Okay, so in addition to watching this video, you're going to have an assignment on the Big Ideas site. You're going to want to log in to demo.bigideasmath.com and complete the Graphing Parabolas 2 assignment. If you have any questions, reach out to your teacher, and hopefully this helps. Again, you can reach out via email, Google Hangout, things like that. If you have any questions, let us know.